So hello everyone, we are from group 5 to S1 class. We want to explain our presentation about breadth first search in Python. Before we start, let us introduce ourselves. My name is Fajar Arifianto Mustika and my partner Muhammad Syahril Syahbani. Python programming language. Python is an interpreted object-oriented high-level programming language with dynamic semantics. It's high-level built-in data structure combined with dynamic typing and dynamic binding make it very attractive for rapid application development as well as for use as a scripting or glue language to connect existing components together. Python's simple, easy to learn syntax emphasize readability and therefore reduce the cost of program maintenance. Python support modules and packages which encourage program modularity and code reuse. The Python interpreter and the extensive standard library are available in source or binary from without charge all four major platforms and can be freely distributed. Definition breadth first search. Breadth first search is an algorithm for traversing or searching for tree data structure or graph. These search methods begin at the root of the tree by exploring each neighboring node at the same depth before moving at the next depth according to its depth level. In other words, breadth first search is an important graph search algorithm used to solve many problems, including finding the shortest path in graphic and solving puzzle games. Many problems in computer science can be considered in the form of graphs. For example, analyzing network, mapping routes, and scheduling are chart issues. Graph search algorithms such as breadth first search are useful for analyzing and solving graph problems. Basic understanding breadth first search. As the understanding in the previous chapter, here we will discuss the basic understanding of breadth first search algorithm that perform an extensive search that visit a broader node, visit a node, and then visit a node neighboring that node first. Furthermore, nodes that have not been visited and are adjacent to the nodes that have been visited, and so on. In the graphic is a rooted tree that all nodes level D are visited before the node at level D plus 1. The algorithm requires a key queue to store the node visited. This node is required as a reference for visiting neighboring nodes. Each node visited is entered into the queue only once. The algorithm also requires Boolean tables to store nodes that have been visited so that no nodes are visited more than once. Breadth first search performs the search process on all nodes that are on the same level or hierarchy first before continuing the search process. How breadth first search works? First, enter the end node or root into the queue. Take the node from the beginning of the queue and then check if the node is the solution. If the node is the solution, the search is complete and the result is R return. If a node is not a solution, enter the entire node neighboring the node or child node into the queue. If the queue is empty and each node is checked, the search is complete and returning the solution result are not found. Repeat the search from the second step. Next.
Application the breadth first search. First, device navigation. Its usefulness is to facilitate the search for the nearest location by utilizing the location of the coordinate point. Using breadth first search becomes faster and easier. If the tree is very deep and the solution is sparse, the first lookup or the DFS may take a long time, but if we use BFS, it can be faster. Web crawling. Use graph traversal techniques for building the index. The process considers the source page as the root node and start traversing from there to all secondary pages linked with the source page. Has an innate advantage here because of the reduced depth of the recursion tree. 3. Garbage collection. Garbage collection is done with a Chinese algorithm which utilizes the concept of breadth first search. Unless discovery of failed nodes in a P2P network. Most torrent clients like BitTorrent, uTorrent, BitTorrent use the mechanism for discovering something called seeds and pairs in the network. Next. Implementation BFS in Python. Before learning the Python code for breadth and its output, let us go through the algorithm it follows for the same. We can take the example of Rubik's Cube for the instance. Rubik's Cube is seen searching for a path to convert it from a full mess of colors to a single color. So comparing the Rubik's Cube to the graph, we can say that the possible state of the cube is corresponding to the nodes of the graph, and the possible action of the cube is corresponding to the edge of the graph. Next. This is a source code with Python and output. Next. Explanation. Now we will see how the source code of the program for implementing reversals in Python. Consider the following graph, which is implemented in the code below. In the above code, first we will create the graph for which we'll use the BFS. After the creation, we will create two lists, and one to store the visit node of the graph and another one for storing the nodes in the queue. After the above process, we will declare a function with the parameter as visited nodes, the graph itself, and the node respectively. And inside a function, we will keep appending the visit and queue list. Then we will run the while loop for the queue for visiting the node, and then we will remove the same node and print it as it is visited. At last, we will run the for loop to check the not visited node and then append the same from the visit and queue list. As the driver code, we will call the user to define the BFS function with the first node we wish to visit. Next. Pros and cons breadth versions. Pros: 1. It won't be deadlocked. If there's one solution, then BFS will find it. And if there is more than one solution, then a minimum solution will be found. 3. Use to find the shortest path between the first. 4. Find the cost goal in less time. 5. Checking graph with before finish. Cons. 1. It requires quite a lot of memory because it stores all the nodes in one tree. 2. It takes quite a long time because it will test and levels to get a solution at the first level. 3. May get trapped in searching useless path. 4. If solution is far away, it consumes time. And less memory constraint as it stores all the nodes of present level to go for next level.
So that's all from us for our presentation. Thank you for watching. See you next time.